Hi everyone. In single replacement reactions, there is a switching. It's like there are two people dancing, and then someone else comes and takes the lead and switches places with the other person. So when we are predicting single replacement reactions, you have one element reacting with a compound. And that element, if it's a metal, it will switch places with the other metal. Or if it's a metal, it will switch places with hydrogen. And then you probably won't see too much of it in this class, but nonmetals will switch places with nonmetals as well. So in our first case, we have zinc solid is placed into a solution of iron 3 nitrate. So we can write out our reactants first. We have some zinc solid, and then we have iron 3 nitrate. So iron 3 nitrate has iron 3, Fe3+, and then nitrate, NO3 minus 1. The only possible combination of those is crisscross, Fe parentheses, NO3 parentheses 3. That way there's 3 minus 1 charges and 1 3+ charge. Those charges balance out. So now you'll switch places between the metals. Zinc switches with iron. So now iron will end up alone, and then zinc will end up with nitrate. Now, this is kind of a memorized thing. If zinc gets a charge, then it's +2. And also, if silver gets a charge, it's +1. The transition metals can have a lot of different charges, all those metals in the middle of the periodic table. But zinc, if it's charged, it's always going to be +2, and silver is always going to be +1. So zinc has a +2 charge. Now I know you might want to say that zinc just comes in and hangs out with 3 nitrates. I know you're tempted just to say that zinc nitrate formed would have this formula, but that is an impossible compound. Zinc has a +2 charge, but nitrate has a -1 charge. The only combination of those that will balance out those charges is to have 2 nitrates per zinc, not 3. This NO3 doesn't change. That's a polyatomic ion on our polyatomic ions list. Those go to the other side and don't change, but the numbers of them in a formula can change. Like we started out with 3 of them in this case, and then only 2 in the product. So now we have written reasonable products and reactants. Now we will balance the overall equation by changing the coefficients in front of our reactants and products. So on the left, we start out with 1 zinc and 1 iron, and up 3 NO3s. Now I think it's easier to balance NO3s instead of Ns and Os separately. There's a lot less work that way. As long as NO3 doesn't change, then it's easier to balance the entire polyatomic ion. And then over on the right, we have 1 zinc right now, and 1 iron right now, and 2 nitrates. So we do not have the same number of nitrates on both sides. That issue from the previous problem of having 2 of something on one side and 3 on another. You need to go for the least common multiple of 2 and 3, 6. Try to have 6 nitrates on both sides. You can do that by putting a 2 in front of FeNO3. I would write it right here, but there's no space. So if you put a 2 there, then you'll have 2 irons, and 2 times 3, 6 nitrates on the left. And now we want to balance that nitrate over here. We had 2, but if we put a 3 in front, we'll have 3 times 2, 6 nitrates on the right, and also 3 times 1, 3 zincs on the right. All right, so we're balanced for nitrate now, 6 on both sides, but we're not balanced for iron. 2 on the left, 1 on the right. Put a 2 in front of iron over here, and now you've got 2 irons on both sides. And put a 3 in front of zinc over here, and now you have 3 zinc atoms on both sides. Now we've balanced so that there's just as many atoms of each element on both sides of the equation. That way, zinc atoms are not being created or destroyed, and iron atoms are not being created or destroyed. Overall, the number of atoms of each element and the mass will stay the same according to the law of conservation of mass. And in our last problem, solid calcium is placed into water. All right, so calcium is solid and it reacts with water. Now you know that water is H2O. But it is a lot easier to predict the products of the reaction if you write water as HOH. That way you won't switch too many hydrogens. Ultimately, calcium and other metals should only switch places with one hydrogen. So write it as HOH so that calcium will trade partners, and now calcium will be with OH. So calcium will be next to OH, but it's not going to be CaOH. That has an impossible balancing of charge. Calcium is in group 2A, so if it has a charge, it's plus 2. In hydroxide, that OH, that has a charge of -1 from the list of polyatomic ions. So crisscross, you need 2 hydroxides per calcium ion. That's the only combination of calcium and hydroxide that's possible. And then finally, calcium had switched places with hydrogen, so now hydrogen is going to be alone. But you don't write just H. Hydrogen is a diatomic element. If it's by itself, then it's H2. So you got H2 being formed. You have now reasonable reactants and products. The next step is to change the coefficients in front of things so that you have just as many atoms of each element on both sides. We're balancing the equation. Right now there's 1 calcium on the left and 1 H on the left and 1 OH on the left and 1 calcium on the right. 2 H's on the right and 2 OH's on the right of that arrow. So we're balanced for everything except hydrogen and hydroxide here. 2 of each on the right, but only 1 on the left. But if you put a 2 in front of HOH, then you'll have 2 H's and now 2 OH's balanced.